Thank you everyone for joining us today. This is one of our first events of the spring semester, so we're very excited to start off with all of you and with Arpit, our Raghunathan Fellow. My name is Salman Rafe. I'm the program manager at the Mittal Institute. If you have any questions about other of our programs that are happening, you'll see a bunch of these pamphlets kind of lying around the room, where you can find more information on some of our other seminars. There's more being added at this time as well, but you'll get a pretty good overview of what else is coming this semester. But I just want to give a very brief intro just to say that, again, thank you for joining us, and also just give a little bit of background on our fellowship programs before turning it over to our moderator. Our fellowship programs bring a handful of scholars from the region to Harvard with us for anywhere from a semester to a year. And the Raghunathan Fellowship Program is actually our longest running fellowship program. I think we've had at this point almost a dozen scholars over the past 10 years or so. And so it's been a real pleasure to kind of see that program consistently bring just incredible talent from a wide array of disciplines from the region to Harvard, which is obviously both a benefit to the scholars themselves, but really a benefit for all of us and the Harvard community to learn from experts from the region. So again, I'll leave it to our moderator to give a firmer or more formal introduction for Arpit, but I will just give a brief introduction to our moderator. S.V. Subramanian, also known as Subu affectionately by us and many others at Harvard, is a professor of population health and geography at Harvard University. His primary appointment is in the Department of Social and Behavioral Sciences at the T.H. Chan School of Public Health and the Harvard Center for Population and Development Studies. He's also the faculty chair of the Center for Geographic Analysis. His other affiliations include the Department of Sociology, the Weatherhead Center for International Affairs, and us at the Mittal Institute. He is also the founding director of graduate studies for the interdisciplinary PhD program in population health sciences at Harvard. Subu, thank you so much, obviously, for one, connecting with Arpit while he's here with us this year, and also for chairing today's session. Otherwise, I'll turn it over to you.
Sure. Thank you so much. So this is my great pleasure, to be here, and then to have the opportunity to introduce here Dr. Arpit Shah. Arpit and I have been working. Well, I got to know Arpit over the last few months, and it's been a great pleasure and honor to engage in a bunch of papers that we are currently working on a theme that Arpit has worked on for a few years now. As Salman said, it's Arpit Shah is a Raghunathan Fellow at the Mittal Institute for this academic year. He'll be here with us until the end of May. His primary appointment is in India as an assistant professor, very soon associate professor, hopefully, fingers crossed, in the public policy department at the Indian Institute of Management in Bangalore in India. The thing that I find like Arpit's work, I mean, obviously it's the big focus of his work is on climate injustice, but where I feel that his work like really is kind of very novel is that he intersects the social determinants piece with the environmental determinants. And I think this has been a kind of coming from the School of Public Health, which has a very strong environmental health department, as well as to some extent social and behavioral sciences, but I've very rarely seen these two fields kind of merge, because both are kind of environmental, if you think about it that way, contextual, you could say, in the same way. So I think like what Arpit has been thinking about and obviously doing with some really kind of data intensive work in this domain, working at this intersection is extremely novel and very interesting to me to learn these things. Arpit works with the very high resolution administrative and survey data, as well as remote sensing data or data access through remote sensing imageries. His research has been well funded by EGAP, and needless to say, he has published in very leading journals, including demography, urban studies, and environmental research letters. I'm going to hand over for the next 1 hour to educate us on this intersection between, social cost and climate change or climate-related variables and inequality in India. Thank you.
Thank you so much, Prabhu, for the introduction. Before I begin, I'd like to thank the Mittal Institute for the fellowship and for this opportunity to be here, and everybody at the institute who've been so kind and warm throughout and made this such a great experience. This is the broad content of what I'll be talking about. I'll talk about why is it important to study caste in the context of heat in India. Then I'll do something which I've not done before, which is take a risk and present two papers in one presentation. I'll talk about inequality in occupational and residential heat stress exposure. These are two separate papers. Both of these are attempting to quantify and describe this inequality in India for the first time. So we are not going into causal mechanisms in either paper. I should have enough time. I'll take around 45 minutes for the entire talk. And then I'll talk about some of the future research we are doing. The co-authors on both papers are listed on the slide. I'd like to point a couple of things out. So Anish Sugathan, who's on both papers, he was a postdoc at Harvard from 2013 to 15. Naveen Bharti, who's on the second paper, was a Raghunathan Fellow here in 2020. We are using a tiny bit of what Anish did all those years ago. We are using slightly more of what Naveen did 5 years ago. So I think there's more to thank Harvard for than just my fellowship. And more to thank the Mittal Institute. Okay, coming to the topic of heat and caste, I think this audience will be broadly familiar with the importance of heat, but I'll just quickly go through this. This is a headline from the Hindustan Times in 2022. South Asia engulfed in heat. You see all these images with everything looking red. So 2022 was a record-breaking heat wave in its time. It broke, I think, 70, 80 or 100-year heat record. 2023 broke the 22 record, 2024 broke the 23 record, at which points records start to become meaningless if they are broken every year. We already know that January of 2025 was the hottest January on record, so it's possible this year will be similar. This is, again, images from newspapers showing how people respond, adapt to heat, right? So, staying hydrated, just pouring water over yourself. This is women changing their clothing. So you adapt through different clothing mechanisms, try and cover yourself as much as you can to reduce your exposure. Bottom left, you have an image of women fetching water from wells, which is, a reality in many parts of India. And this is actually getting worsened because these heat waves now coincide with drier spells where, water wells and so on dry up. So you actually have to travel farther to get the same water in extra heat. And climate science tells us that heat waves in India are 30 times more likely because of climate change. So this is from the World Meteorological Organization. And these extreme temperatures, it's important to study them because they have multiple impacts, right? So the health impacts are the first thing. So heat leads to mortality. 2011 heat wave in Ahmedabad, led to 1,500 people dying in 2 days because the hospitals ran out of ORS and cold compressed bandages, which is the first thing that you apply. Heat has been shown to impact birth rates, birth outcomes. There's recent research in Africa showing that people born during periods of high heat tend to have mental health outcomes later in life. So, the causal links are not very clear, but this is something that's been documented. Heat obviously also has, follow-on economic impacts. So if you're a daily wage laborer who has to miss work because you fall ill, that leads to wage loss. There's now research showing that heat also leads to losses for firms. So in factory settings, workers are less productive if it's hot. There's now interesting research on software developers who typically work in air-conditioned rooms, but it's been found that teams of software developers collaborate less well because when it's hot, because they are more irritated when it's hot, which is a strange kind of phenomena, but that's been documented now. And heat also is linked to democratic processes. So in India, typically the central elections happen in the summer months. April, May is your election season every 5 years. So people are less likely to go out and vote if it's very hot. There's new research which shows that judges in India tend to hand out more convictions on hotter days. Again, it's possible that like the software developers, judges are also more irritated, they hand out convictions, but so heat basically impacts fundamental democratic processes. In many ways, in today's climate, people are worried about many threats to democracy. I'm adding one more to the list here. Now, why is it important to study caste in this context? So a lot of you will be familiar with caste. I'll quickly go through it, in case you're new to this phenomenon. But the caste is a historical system of social stratification. It's also hierarchical. So, people are divided into castes, but it's also hierarchy. So one caste is superior to another caste. So uh, I'll go through that in a bit more detail, but caste is basically, it's analogous to race in the US, where one race is considered superior to the other. I mean, at least historically. It's hereditary. It perpetuates through endogamy. So different jati groups marry among themselves. Children belong to the same caste, so that's how it propagates over time. The system is now 3,000-4,000 years old. And caste is fundamental structural feature of Indian society. So it influences diet, religious practices. Uh, Caste influences economic outcomes. So every census or administrative survey that you see, uh, people from marginalized caste groups tend to be financially, less better off. Impacts your life outcomes. So they tend to have, on average, less educational attainments. Uh, in this piece of research, we analyze four main caste groups. So, we look at scheduled castes, the SCs. These are the formerly untouchable your castes, now also known as Dalits. Uh, Historically, they've been among the most marginalized groups in in Indian society. Uh, the 2011 caste census estimates that they're around 17% of population. We don't have an accurate census after that, so that's the latest estimate available. Though later sample surveys which people have done tend to estimate SCs between 15 and 20% of India's total population. Second is the scheduled tribes. These are tribal communities who've historically lived in geographic isolation. So many of these tribes lived in forests, for example. Uh, they also tend to be marginalized. Their outcomes tend to be similar to SCs, uh, around 9% of India's population. Uh, then you have the OBCs, also known as the other backward classes. Uh, they've been discriminated against historically, but because of their numbers and other features, they tend to be politically dominant. So socially marginalized, but politically they have more power than SCs and STs. And finally, others is a residual category. If you don't belong to SC, ST, OBC, that's others is where you end up, or that's the residual category which is used by the government of India. So this is the fourfold scheme also used by the government of India for affirmative action. So seats in educational institutes, government jobs are reserved along these lines for SC, ST, OBC. So others is this residual category, which tends to be the historical quote unquote upper caste, socially and politically dominant. Their outcomes tend to be among the highest in terms of life, education, uh, economic outcomes, and so on. Now, caste. Our argument is that caste will influence your heat exposure through two channels. Uh, and we are attempting to quantify these two channels. So the first channel we focus on is occupational segregation. Caste historically has also been a means of dividing people by occupation. So, occupations and caste groups also intersect. So, a son of a blacksmith would be a blacksmith, that kind of logic. Individuals from different caste groups historically have been unevenly represented in different types of jobs. And our point here is that these different jobs have different environmental exposures. So, for example, if you're an agricultural worker, working in the summer, uh, outdoors in the heat, your exposure is very different as compared to if you're a white collar employee sitting in an air conditioned room. Uh, and you can think about this. There's agriculture is one, but construction workers, street vendors, many different categories of occupations will have different exposure. Uh, and even though some research says that caste norms are diluting as India modernizes, the economy becomes more market oriented. Uh, Recent research continues to suggest that caste still matters in India's modern market economy. So for example, if you look at a list of startup founders in India, and you try and classify their caste from their last names, you'll find predominantly they happen to be others and not the other three caste groups. So that historical privileges continue to play a role even today, right? And there's various ways in which occupational segregation could operate. I'll let a cartoonist explain one of these channels for you. Uh, there's various other ways. In addition to this, there could be pure discrimination. There could be preferences for doing certain types of jobs. We are not going into the channels here, but there's various reasons why caste and occupation seem to intersect. Second channel, which I'll kind of explore in the second paper I'll present, is residential segregation. So similar to occupation, individuals from different caste groups are also unevenly distributed with regard to their places where they live. And these different locations, residential locations, also have different environmental exposures. So if you happen to live nearer a green space or a lake, you're likely to face much less heat as compared to if you're living, right next to a factory. To show you how residential segregation, this is racial residential segregation has been well documented in the US. We are studying this in the Indian context. I'll come to the findings later, but this is a map of a village in Karnataka that we digitized. Different colors on the map. So the different kind of blocks on the map represent houses of people, and the different colors represent the caste group of the family living in that house. You can clearly see this is not a random distribution, right? So Harijans, which are in this green area, are at a corner of the village. Lingayats, which tends to be a dominant jati in Karnataka, is occupying the center of the village. Now, if let's say a green space were to be located right in the center here, you would naturally expect certain caste groups to have better access to green cover, better environmental or lower environmental harmful exposure, right? Okay. Coming to the first paper, which is evidence in occupational inequality in occupational heat stress exposure. In this research, we focus on outdoor occupational exposure. So basically, we look at whether caste determines how much exposed you are while you are working outdoors. So does the caste play a role in this context? Examples of outdoor occupations, like I said before, this could be agriculture, construction work, municipal work, and so on. So, sanitation workers working for, city governments, for example. These typically tend to be moderate to heavy workloads. And if you're outdoors in the heat in India, you will tend to have low cooling access. So it's not as if, you have a fan or an air conditioner. You're just exposed to the elements. At most, what you could have is access to some shade. Nothing beyond that, right? At this point, I think important to point out, though we don't study it here, indoor exposure is also important, or equally important. You could be working indoors in a factory, which has very poor ventilation, no fans, no ACs. That could also lead to heat stress exposure. That's something we are not covering in this research, though it's also important and needs to be studied. We define exposure as occurring if you're working outdoors at a time when we use a metric called the UTCI, which stands for the Universal Thermal Climate Index. If any of you've done, Google searches for local weather, nowadays, in addition to the actual temperature, it shows you something called the feels like temperature, which is a different metric. UTCI is basically your feels like temperature. So in addition to temperature, it incorporates wind speed, humidity, and solar radiation. So at the same air temperature, if the wind is blowing, you'll feel cooler. That's the basic logic. If it's more humid, you'll feel hotter. Your body actually responds to a combination of all of this and not just air temperature. So UTCI is in fact a better metric. The feels like temperature is a better metric to understand if you'll have health impacts because of the temperature you're facing. We define exposure as occurring if UTCI exceeds 32 degrees Celsius, which is close to 90 Fahrenheit. And you're working outdoors. This threshold is from the biomedical literature, which kind of suggests that any moderate to heavy workload at such temperatures is almost definitely likely to lead to heat stress in your body. Data we use for this project is, we use the periodic labor force survey. This is an annual survey conducted by the government of India, which captures occupational information. We use the 2022 round of the PLFS. When we started the project, this was the record-breaking heat wave of its time. We also did not want to use 2020 and 2021 because of the pandemic. So, the labor force conditions were not representative at the time. PLFS, provides occupational information in addition to a bunch of individual and household socioeconomic data. So you have, caste, wealth, household assets, so on and so forth, education levels of the head of the household, age, etc. PLFS also provides location in terms of the district in which the household resides. So you can, specify that this household which was surveyed belongs to this district. This is a nationally and state representative survey with a sample size of more than 400,000. We focus on the summer quarter, which was April to June in 2022. This is the summer season in the Indian context, so it's slightly earlier than the US summer. We classify, so PLFS tells you which occupation the household belongs to and the location of the place where the work happens. So occupation could be agriculture, location could be, inside a building. So in which case you are probably working in an agri-business kind of setup, or it could be outside, which means you're probably working on the farm. So for every occupation, both of these are captured. Using these two, variables, we classify every activity as occurring either indoor or outdoor. We used, 3 coders to kind of code this data set. In 95% of occupations, our codes matched all 3. So, it's fairly intuitive which one's indoor, outdoor. In the ones which didn't, we, kind of used the majority vote. But even if you remove those occupations from the analysis, the results don't change. So we combine this, PLFS data on indoor, outdoor, and caste and location with high resolution UTCI data. So we basically have hourly information at a resolution of 10 kilometers, which is sufficient to do district level analysis. A district on average is 600 square kilometers in India. So we use this hourly information, we match it to the location of the worker's work, which is the district. And then we do a bunch of robustness checks. I'll tell you quickly about those. But we also do further confirmation using a separate survey, which is the time use survey. Which also captures some of this data in more detail. Time use survey actually captures an individual's how do they spend their day, and they capture it in 48 chunks of half an hour each, which is more detailed than what the PLFS does. But unfortunately, the time use survey was only done for 2019, whereas we were interested in 2022. So we use it only as a robustness check. Okay, just to kind of show you the results, right? So this is a map of India's districts, which shows the number of hours for which the UTCI exceeded 32 during this summer quarter. What you basically see is that in most of India, UTCI is exceeding 32 for 9+ hours a day, which is a very high threshold, right? So you're practically in heat stress conditions all of the time. And when you consider that most of these hours will occur during the daytime. Nighttime is when things cool down. The daytime exceeding of 32 pretty much overlaps with your work day. So you're working when the temperature is hot, right? So this is the almost perfect kind of overlap. The average district had a UTCI exceeding 32 for 8 hours a day in this data set. Most of them are crossing 9 and 10, but in the average itself is 8. And the ones which are in blue in the north are basically the hill districts in the Himalayas, where you'd expect temperatures not to go high. These are maps by caste group of how much time do these caste groups spend working outdoors in this time period. So, sorry. Okay. Turned on some auto square. Wow. Big bucks. I think we are revealing all the secrets of the presentation. Oh, that's go back. Back, much. Okay, I'll just do it. One second. Okay, so now that you've seen the whole presentation, let me go back and repeat it again, right? So
From the top.
I won't subject you to that, but yeah, we'll start from where we left off. Okay, so this is a map of time spent working outdoors by caste group at the district level. Lowest category is 0 to 131 minutes, which is 0 to 2 hours and 10 minutes. Highest is in the red, which is 194 minutes plus, which is 3 hours 15 minutes. So 3.25 hours. Right? Basic, I think, thing to point out in this map is SCs and STs are mostly in the red. They're much more in the red than others in OBC. Second thing, I think the numbers are not on the slide, but on average, we find that others spend 27% of their work hours outdoors. So if they're working, 27 out of every 100 minutes is outdoors. If you move down to STs, which are working the most outdoors, out of every 100 minutes, they are spending 48 minutes working outdoors. So this is a significant gap even without doing numerical analysis. This is just a significant, uh, 27 to 48, right? And SCs is closer to 43 minutes per 100 minutes outdoor.
So can I just,
Yeah.
one clarification? So how is that how do you get this? Is it through the prevalence of ST in a particular district or the number of?
So from the survey, we just do, STs in the district and how much time did they spend outdoors.
So the number of STs, not the prevalence of STs. So if you take a district, is it the actual number of STs in that district? And then their
Not
exposure?
actually, if so for a scheduled tribe individual in the district, they're likely to be spending 194 plus minutes working outdoors.
Oh, this is just outdoor. Okay,
yeah.
this is not heat exposure yet.
This is not heat. This is just.
Oh, got it. Okay.
This is just time.
Never
Yeah.
mind. Yeah, that's okay. Yeah.
This is kind of trying to show the first
Yeah.
argument, which is there is
So,
occupational segregation by caste. Just the basic argument before I go to heat exposure. Yeah.
It's from this we can't tell whether the district has a high proportion of STs or STs.
No,
The
this
district
is
would have
an ST in the district working so much outdoors. This does not tell you anything about how many ST individuals does the district have. That we'll do later. But this is just kind of trying to visually show that there is occupational segregation does exist, at least in terms of how likely are you to work outdoors. So occupations which require outdoor work are more likely to be, or are disproportionately likely to be taken up by SC/ST individuals. That's, I think, the argument from this slide.
in majority of the districts.
In majority of the districts, and the average is also 27 to 48. I think that also tells the same story. We formally analyze this, so my apologies if you're not a regression expert. We formally analyze this by our dependent variable here is exposure. I won't go into too much detail here, but we model exposure of an individual as a function of their work hours, their caste group, which is group, and the interaction between work hours and group. Our basic argument here is that this interaction term will be positive, which basically, in an intuitive sense, this would mean, if it were positive, this would mean that if I increase the work hours of SC, ST, OBC, others, everybody by 1 hour, a positive interaction term for anybody other than others would mean they are more likely to be facing exposure as compared to others. And like I said, exposure occurs if your time of working outdoors overlaps with the hourly UTCI information on whether it exceeded 32. We control for a number of factors, including household spending, education of the head of the household, number of work hours is in the slide, age, gender. We also control for state. So this is basically an intrastate analysis. Any results that you see now would basically mean that STs in the same state are more exposed than others than OBC in the same state. It's not a average national analysis trying to say that STs are living in hotter states and so on. So that could be another way exposure could occur. We are basically saying this is all happening in the same location, in the same state. This is the results of our regression. What we plotted here is on the x-axis, number of hours that an individual works in a day. On the y-axis, your exposure during those hours of work. The red curve for red curve for others is kind of lower than the, let's say, the green for SC and ST. Yeah, I think basically I've shown results for 2019 also as a robustness check. Our primary analysis was 2022 heat wave. What this basically means is if an others individual is working for 5 hours in a given day, on average in this quarter, they're likely to be exposed for 2.1 hours. 2.1 of those hours will be outdoors during heat stress conditions. If you're a scheduled tribe individual, it's likely to be 2.6 to 2.7 hours. So there's a half an hour, extra exposure every single day, which, if you think about it, in summer conditions like you have in India, doing this daily for months on end and years on end is likely to add up in terms of your health impacts. You may not see the impacts every day, but this will add up just over time.
So did the SC ST difference narrowed in 2022? That's the purple or magenta and
We kind
green.
of see we actually see a slight flip between SC, ST, yeah,
So the green and magenta are now
are
on top
flipping.
of each other.
Yeah, are getting closer to each other.
Uh,
But our preliminary finding on others and OBC doing better, that doesn't change.
So in 3 years, their exposure actually, everyone's exposure a little bit comes down, is at least at the upper end. Like the longer you
So
work,
this is,
because the
yeah, I
scale
mean,
is the
this is
same, right?
scale is the same. This is the, yeah, exact same scale on both. Okay, this is
So
slightly technical, but this was also a function of the threshold that we use. So 2022 was actually, this was a bit surprising for us. We expected
Yeah.
22 to be higher.
yeah,
It's a stronger heat wave.
yes.
What we later discovered is this was also a function of the UTCI threshold of 32 that we use. You increase the threshold to 35, which is, much stronger heat stress conditions, then 22 is a stronger heat wave. So
But
in
on the same one,
2019,
it
yeah,
may not
in
be.
2019, temperatures tended to exceed 32. They didn't exceed 35 so much. In 2022, it shot up through 35, and so it's slight function of what exposure level we are using. But fundamentally, our argument kind of still holds, irrespective of what threshold you use. Okay, so in terms of robustness checks, I won't show you all the results here, but we've also tried this with an alternate heat stress metric called the environmental stress index, which is not exactly the UTCI. Same results. We've also done this with an alternate labor force data set called the Consumer Pyramids Household Survey. We tried this on some samples of working population adults. So surprisingly, PLFS, though it's illegal in India, also captures some amount of child labor. They have people working reporting ages of 12 and 13. I'm not sure how that gets into official government documentation when they deny that this is happening. Yeah, like I said, we've tried this with different UTCI thresholds. So we tried this from every threshold from 26 to 35. In reality, different occupations need to consider different thresholds. If you're a construction worker lifting heavy loads, temperatures at which you will experience heat stress are not the same as if you are, let's say, a street vendor who's mostly sedentary or standing in a given place. So we've tried this to multiple thresholds. It doesn't change the results. We've also tried models where we gave people the flexibility to avoid heat. So one of the things, anecdotally, which we know is people try to shift their work hours if it's very hot. You start early in the morning, finish late in the evening, maybe break in the afternoon. You give this flexibility, still, same inequality persists. Finally, I think this one is interesting. We tried this using the time use survey data, which like I said, captures every half an hour of that person's, day. This is what exposure looks like. Time use survey also captures non-work information. It's just a survey on how you spend your time. PLFS does not capture anything which is non-work. It's a labor force survey. Time use survey also, so we are able to capture your non-work kind of exposure. I think 2 or 3 things to point out here. Firstly, non-work exposure is also important. This could be exposure, let's say, women fetching water from wells is not considered labor force by the government of India. That would go into non-work exposure. Right? It's technically not an economically paid activity. Or, dropping kids off to school. This is where women would be more exposed traditionally. Stuff that requires you to go outside the house, which is not labor force. So non-work exposure is not that trivial. It's one close to half or 1/3 of work exposure. So it's an important piece. However, we also find that all of the inequality that we see is in work exposure. Non-work exposure, you don't see inequality. Everyone's pretty much at the same level of 20 to 23 minutes. When you look at work exposure, it varies from 44 to 65 minutes. From others to ST. And as you'd expect, on the x-axis, you have time of day. So, starting at midnight, ending at midnight. Most of this exposure is occurring during the daytime hours of 8 a.m. to 8 p.m. At night is when things cool down.
And this would be paid work or also include?
Work exposure is paid work, and non-work work is, yeah, if you're paid
all
for
work is paid here.
In this survey, yeah, all work is paid, non-work is non. Even though, there's definite argument that fetching water is economically necessary, though this is just the government classification of this is.
No,
work, yeah.
but I was more keen. So
This
let's
is
say
paid
there
work,
is
yeah.
underemployment, right? Even if it's paid, then you just don't have enough to work. so you won't go out even, and that might happen more likely with the ST.
That's
Right.
true. Yeah. I
If
mean,
there is
the-
underemployment.
correct. In which case, yeah, if they are actually looking for, let's say, work on farms and so on, underemployment would mean this is artificially lowering their exposure in many ways.
Because I think this control that you have shown is interesting, that there is no gap, that I should not expect to some extent.
We were not expecting,
Yeah.
no inequality, non-work exposure,
Yeah.
but that's what we ended up finding. Uh, yeah. Okay. So yeah, this is what I had on occupational heat stress exposure. I'll go to the second paper now, but I can pause if there's question, comments.
Would you mind going back to the UTCI map, please?
Sorry, this one?
Yeah, so clearly, broad stretches of the country are obviously deep red. I was wondering what is the reason for, Kerala and North Karnataka sort of not being as red as the other areas?
I mean, one is it could be the Western Ghats. Second, it could be the sea kind of moderates the influence on the coast. So Kerala is obviously almost an entirely coastal state, right? On the west coast. Could be the sea moderating some of that influence. Having said that, just because they're yellow doesn't mean it's low, right? They're still exceeding UTCI for 5, 6, 7 hours a day. It's just not 9 hours a day. I mean, that's what the rest of India. So I think by comparison, they are looking low. It's not really low from an objective sense. Primarily, I mean, my primary reason for saying that would be most of this exposure is during the work time hours. Because, by default, night is cooler than day. So if you're having something exceed 32 for 6 hours a day, it's all during the, 10 to 4 in the afternoon. Yeah.
Wanted to understand, is this normalized for the entire year, or like
This is the summer season.
just for summer?
This is
Okay.
April to June quarter. Yeah.
So, is it possible to further disaggregate the OBC in either of the data sources that you use, the LFS and CPHS?
No, not in these data sets.
Right.
The next paper I'll present, it's possible to disaggregate down to the Jati level. Not in these ones. I'll come to that. That's a good question. We're using OBC as a homogeneous category. They're not exactly homogeneous, right? It's a hugely varied, and it's a large. 44% of India is bigger than most countries, including the US. Yeah.
So I'm asking, because in rain-fed areas, in the summer period you're taking into account, often it's an agricultural fallow season. So this follows your question about unemployment, underemployment. A lot of agricultural work doesn't happen in that season.
In that summer, right? This is if they've reported working outdoors in the summer. So this is, you're right. So, I mean, actually agricultural work would be low in the season because, yeah, right, it's fallow season. This is still happening because these are people that are still reporting that we are doing some work outdoors in this season. So this is just the direct data from the survey.
I think it'll be worth clarifying upfront.
Yeah,
It's not infinite. It's a direct question.
This is a direct.
Whether they were working outside or not.
It's a direct question whether you were working and your location of work. We are not making inferences here. Okay. Coming to the second paper, residential heat stress exposure. Well, I showed you this village map where jatis are segregated in space in the village. This is a more clearer image. This is a famous kind of photograph taken by the South African photographer Johnny Miller. This is a drone shot of Bombay. This is one of the famous images that he took. On the left, you have Dharavi, which is Asia's largest slum, right next to a creek. On the right, you have what looks. This is actually a commercial kind of Bandra Kurla complex, which is a commercial site. But if you had elite gated communities in Mumbai, this would look like they would look pretty similar. I mean, environmental inequality is right here to see visually, right? One would expect the areas on the right to be cooler. There's more green leafy trees and so on. On the left, you have absolute absence of greenery. And you're bordering pollution and so on. That's a separate matter. But this is also visual proof of a lot of us have heard anecdotally that elite communities or gated societies in India tend to be right next to slums. This is kind of a visual uh, or visual proof of that. So for this project, we're studying the city of Bangalore. We combine several sources of data. So we use this survey called the Government of Karnataka survey. Uh, this was practically a census conducted by the state government, but there's regulations in India that a census can only be conducted by the central government. So they can't call it a census, so they ended up calling it a Government of Karnataka survey. And they kind of discuss this as a census scale micro data set. But it's for all practical purposes, a census conducted by the state government. They collected detailed information on caste language. So in this case, they had actual jati level, information on thousands of jatis in the state. So everything that a census basically, collects. So religion, education, income, everything at the individual level. They also collected a large vector of household assets. So you can kind of map the wealth of the household.
What year was this?
This is 2015. They've only done this once. For Bangalore, GOKS, so I'll call this GOKS, Government of Karnataka survey for the presentation. They had data on 1.77 million households. At the time, I think Bangalore had 1.85 million households. So it's practically the whole city. Located in 16,000 neighborhoods. These neighborhoods basically are the same as census block maps. So when the 2011 national census in India was conducted, census uses basically a spatial mapping frame, which is similar to the US census. So they divide the country into census blocks, and they go and conduct the census in every single block in the country. Thankfully for us, GOKS used the same block map as this 2011 census. So there's that spatial mapping. And GOKS also provides us the neighborhood identifier, which can allow you to map it to that census block frame. We combine all of this with remotely sensed information on temperature, green cover, lakes. This census block frame, while I'm making it sound simple here, I'll kind of show that this was an enormously complicated exercise, like every piece of research in India. This is what a census block looks like. This is actually how the census uses it. This is a part of Bangalore. They're telling you there's a national highway here, there's a playground here, there's a hospital here. Every block or every square here is the house and the number of the house. So basically, when you ask the Census of India to share the block frame for Bangalore, which is what we did, they had Bangalore divided into 16,000 blocks. They just sent us these PDF files, which look exactly like this, which are not, they're not mapped to a spatial data frame as of yet. You just have 16,000 data files, which are PDFs, which are practically hand-drawn to work with. So we had to manually geo-register such notional sketches. Thankfully, what they do is tell you which ward in the city this neighborhood belongs to, or the block belongs to. Bangalore has 198 wards. So you can look at this PDF and say it's part of this ward of the city. So it's not as if it can be randomly anywhere in the city, but no other information. So you basically have to use Google Earth, all kinds of other secondary information, this hospital, this playground, which highway, to figure out where in space this is located.
Within a ward.
Within a ward. So this is what we did. So this becomes a two-step jigsaw puzzle where you basically fit all these neighborhoods within a ward. Then you fit all these wards together to create a city. If anyone's interested, we are in the process of doing this for Delhi, which Bangalore has 16,000 blocks, Delhi has 32,000. So if you are an expert jigsaw puzzler, please talk to me after the presentation. Join us. We'd love to have you. But yeah, and the second, I think, important point here is this is actually a fitted together map of one ward. You'll also notice that these neighborhoods are not equal in area. The map that they give you is not to scale. So you have to also find out where. You can't just assume that all of these are equally sized. Right? All of this alternate information aside, you have to find out where in space this is located, fit this together. So we fit this whole puzzle together And finally put the wards together. Thankfully, in most cases, we found that either the wards or the blocks are within natural boundaries like roads in this instance, roads or lakes or green spaces. So you'll almost never find a census block, going across a national highway. It'll be bounded, logically to some extent. You fit this together to form a map of the city. So this is, our final map. What we're plotting here is the proportion of SC plus ST in different neighborhoods in the city. I think 2, 3 things to point out here. Firstly, there's no obvious pattern. I mean, areas of high SC, ST concentration are interspersed with areas of low concentration or low, population share. If you compare this, so, just to kind of illustrate this point, I've compared, on the left, you have a map of segregation in Detroit, which is, one of the United States' most segregated cities. Light blue color here is the city center, which is where the black majority population resides, African American population. Red dots here represent the white population, which is typically in the suburbs for the case of Detroit. I mean, there's a very clear pattern where certain racial groups are concentrating in certain parts of the city. You don't have similar patterns in India, which is why it's also important to study India. I mean, the same racial segregation, the way it's operated in the US through historical redlining and so on, this is not how it's operating in India. There's very different things going on. So basically, point I'm wanting to make here is segregation in India is street by street. It's not this area of the city versus that area of the city. Which is, again, this is also a visual indicator of elite gated society right next to a slum. This is what it would look like if you repeat that pattern, throughout the city. We combine, so yeah, once we have this map, you can map it back to GOKS, and now you have data on the neighborhood share, by caste, all of the other indicators that GOKS has captured at the neighborhood level. We combine this with remotely sensed data on temperature, firstly, and information on green spaces and lakes. So we use a combination of manual and algorithmic methods to map green cover from Google Earth imagery for Bangalore. Okay, coming to results. This is a map of, on the x-axis we plotted z-scores here for clarity, but on the x-axis you have population density at the neighborhood level. Increases as you move towards the right. This is a histogram, so y-axis you have density plot. Basic point here is if you look at the curves for, so when we started doing the analysis, we realized Muslim outcomes for Muslim neighborhoods or households were very similar to SC/ST. We split this out in the analysis to just highlight, so religion is also part of this analysis here. Key point here to make is red is the curve for Muslims, green is for SC/ST. They are shifted towards the right. So Muslim and SC/ST households live in neighborhoods which have higher population densities, which basically means they are more crowded. Same results for temperature. If you map out caste group by temperature, the curve, which is red and green, is shifted towards the right. The vertical colored lines show you the mean values. If I were to use statistics, then the mean values for Muslims and ST/STs are 1 to 1.5 standard deviation more than the average temperature for others. In terms of absolute temperature values, this is closer to 0.8 to 1 degree Celsius, or yeah, that's the kind of range. To kind of illustrate why this occurs, this is an actual map of one ward in Bangalore. Sorry, what I've plotted here is different colors here represent share of SC/ST population in different neighborhoods in the world. Darker colors mean these are the parts of the ward where SC/ST is concentrated. The yellow shades are where others and OBCs are, in higher proportion. If you look at where the green cover is located, which is this green shaded areas, they're almost all in the yellow parts of the map. Which is again, kind of showing that SC/STs are living, farther away from green spaces, even within the same ward in the city. You see this directly reflected in the temperature outcomes. To kind of check this, for the whole city, we plotted a map of green space versus temperature. On the x-axis, you have distance from a green space. Y-axis, you have temperature. So what you basically see is as you move away from a green space, temperature increases. This is your mechanism, right? So SC/ST are living, farther from green space, hence facing higher temperatures.
So
So-
this was only restricted to one ward?
This is just to kind of
give a
illustrate the
picture.
point, yeah.
Because
of how
presumably
This repeats across world.
no, but is there a spatial contiguity, like, or that ward line is like, if there's that whole patch, which is SC/ST or OBC, let's say, a purple one. I would expect like that to continue over to the other ward, right?
It might a bit, but in India, for example, like I'm saying, this segregation is also very much street level. So this could be,
But it's not,
sorry,
like,
this-
so because the ward boundary has no meaning per se, right?
ward boundaries. I mean, yeah, ward boundary has political meaning because there's a ward councillor, but yeah, in terms of distance to green cover, it has no meaning.
Or
What
for
we-
people's, like, if there's a slum coming up
Sorry.
there, it shouldn't matter which ward. Like the boundary of
Sorry,
the ward
where did
is,
this- Huh.
so my only question is, like, it might be worth showing like two wards to show like, because that whole purple patch may just extend throughout, so there's nothing unique about the ward.
Yeah, that's a
It's a
fair
more
point.
of a
And yeah,
spatial-
kind of just,
yeah.
I think okay, yeah. So the one point here was within the ward just to visually indicate this, where the green spaces are. But in the formal analysis that we do, for example, if this neighborhood, right, this is a SC/ST neighborhood.
Yeah.
If this is next to a green space in the next
Yeah.
ward, we are agnostic to it. We are just mapping
Okay,
distance.
got it.
So in the formal models that we run, I mean, you need not be closer to a green space in your own ward. But I mean, to kind of give you a highlight of the results, they are farther away from green spaces in their own ward. They're also farther away from green spaces in general. So that holds in both ways. Yeah. So okay, I won't show all of the results here, but broadly what we find through this analysis is they live in denser locations, experienced higher temperature, farther from green spaces, less likely to live in concrete housing, which for practical purposes in the Indian context means they're living in slums. So you either have concrete houses or slums, I mean, broadly. And slums would typically in India mean tin roofs, which are even hotter in summer. They don't cool down so much at night. Less likely to pay income taxes, experience higher micro segregation. So one of the interesting things in this data set is, sorry, I'll just go back here. Like I said, they have household numbers here, not very visible, but so there's 1, 2, 3, 4. So basically numbers every household in the block. In addition to telling you household belongs to this census block, the census, thankfully GeoCase also numbers the household and tells us the household number within the block. And they've numbered households consecutively. So if your household 14, then 15 is going to be your neighbor. So you can basically, what we've then done is map out within the block. What we find is Muslims, SC/STs are likely to be even internally segregated within a block itself. So, forget ward level analysis. If you go down to a census block, which is typically 120 households in India. So an average block is 120 households, population of 600. If there are 30 SC/ST households, they'll be in one corner of the lane. They're not randomly distributed even within that street. They also experience higher macro segregation. So these are segregation metrics from the literature on diversity. Neighborhoods with a majority SC/ST Muslims, they tend to look on average different from the average city demographics. And yeah, finally we do this kind of additional analysis from the health survey data. SC/ST OBC also have less access to cooling at home. So 94% of households who are others will have access to a fan. For ST, it declines to 69%. Air conditioning usage, this was 2022 data. Air conditioning usage for others is 36% of households. For ST in the pop sample is 12%. So you're more exposed to heat, less access to adaptive mechanisms. So all of this kind of adds up. So if you think of the two studies together, they're more likely to be working outdoors at times of heat stress, more likely to face environmentally harsher conditions. When you get back home, you're more likely to be in a house which is hotter, and you're more likely to be in a house which has less access to cooling. It's less likely to cool down at night.
Is
Sorry.
this what data is this?
NFH,
So like
AC or cooler
33% have AC or cooler in India.
in the others category. This is what the NFH is.
Wow, that seems high. No,
AC or cooler, not just AC.
just cooler might
A
be.
lot of this would just be cooler, not AC. But they've clubbed it, so we can't split this one. Yeah.
This is across India.
Hmm. All India level.
94% of Indians have, households have
Fans.
Fans.
This was the NFH's data. You
This
think
is
that's high?
urban?
Totally.
No, this isn't sample of urban India because we were comparing this to city.
Oh, this is urban.
This is urban.
Oh, okay.
Just a question. They're not mutually exclusive, right? Like the same household can have a fan and
Yeah.
It could have both. Yeah.
You're right.
It could have both. So
You're
yeah,
right.
you're right. It's possible. Yeah. I mean, if the numbers for ST, for example, overlap,
Exclusively.
these 12 also have fans, then it's even worse. I mean, then
Or
yeah,
for that matter, that 64 includes the 36.
yeah, then it's even worse. Yeah. Okay, I won't show you all the detailed regression models, but to just wanting to make the point, we've done all these regressions where we controlled for if your green space is closest to you in the neighboring ward, we've done spatial error models, so on. Okay, I'll kind of skip this in the interest of time. I can pause here and see this question. I'll just quickly talk about future research.
You can wrap it up and then
Okay.
we can.
Yeah. Okay. So I think both of these projects are part of a longer term agenda of developing a quantitative understanding of environmental justice. I think this is meant to complement. There's a lot of excellent research now, ethnographic, on environmental justice in India, on how people are experiencing adapting to heat. And that's essential research. We are trying to complement this by doing a quantitative analysis to put numbers at least to signify the extent of this inequality. So because while there's a lot of research on heat, a lot of it is not yet focused on inequality, at least quantitatively, in the Indian context. Next step is to kind of explore the channels through which this operates. There could be multiple channels. For example, residential segregation could be, like I said, SC/ST households have lower financial outcomes. It's possible they could be priced out of real estate market. It's possible that households closer to green spaces are more expensive. They're not able to afford this. But it could also be discrimination, either bottom up or state led. So, state could be, providing better service to certain areas. It could also be bottom up discrimination where people prefer to sell or rent to other people who look like them. So for example, I studied in Ahmedabad, so I'm kind of familiar with that city. But in Ahmedabad, for example, landlords will tell you you can only rent if you don't eat non-vegetarian food. And if you kind of think about it, people more likely to eat non-vegetarian food in India are SC/ST Muslims. So that's the segment you're excluding, right? So there's various ways in which this inequality could operate in practice. That's not been quantified yet. There's ethnographic evidence kind of telling us what the channels are. Though it's but it's also very difficult to quantify. Real estate transaction prices, etc., are tough to get in India. But that's kind of where we want to head next, if possible. Third is to study the health implications of this. This is the first order effects of this environmental inequality. Like I said, mortality, birth outcomes, and so on. So that's some of the work started with Subbu here. But these are the directions in which we are headed. I think that's what I had for today. And thank you so much.
Thank you, Arpit, so much. Maybe I'll just leverage my privilege as a moderator by asking just one question and then we'll open it up. So what's your take on these remotes since you work a lot in this with these data sets? So when we are measuring these things from the satellite imageries, whether it is related to heat or precipitation, droughts, floods, etc. Um, are there good validation study that actually on the ground that's what it is?
I mean,
Like, I mean, how valid are these estimates that the reason I'm asking this is because it's fine to describe that if you're just describing whatever the remote sensing data gives us. However, the bar to use that as an exposure then raises the bar quite substantially, right? Because if I'm going to assign something that I am exposed to as an individual or even a small area, then the misclassification or measurement error in that regard becomes like huge, which we know if it's measurement error, it can actually give you spurious relationships.
Correct.
So I think that's been my one kind of pet peeve with most of the environment, or at least the remote sensed based work, because as a epidemiologist, then if I have to put that hat, then exposure is everything, right? And we even worry about misclassification of exposure even when I ask people, right? Like whether it is income category or education, either people lie or there are misclassifications due to the labelings that I may have. So anyway, have you thought about this issue of like the validity of these measures, especially with regards to its use as an exposure in health
Correct.
studies?
I think there's two. Let's split this into two questions,
Yeah,
right? One is,
please.
let's say, for example, we've used the UTCI here, which
Yeah.
is the fields like temperature, right?
Yeah.
One is whether UTCI, firstly, even accurately reflects environmental conditions on the ground. And secondly, if it does reflect environmental conditions on the ground, does it reflect the exposure that the person actually experiences? These could be two separate sources of error, right?
Yes.
On the first part, there's reasonable confidence. People have done validation studies of UTCI with actual weather station measurements and so on. Seems to do well. So it's reflective of what's happening on the ground. In terms of whether it measures exposure of the person, that's slightly more nuanced. So I would say it does a better job at measuring exposure when you're outdoors, because that's what the metric was designed for. I think Karthik is here. I think so. The Harvard Heat Project is basically finding that a lot of these satellite measures underestimate the heat that people are experiencing indoors. I mean, these satellites are not able to capture what's happening inside the house because all you can have is estimates at the best. Because houses don't cool down as rapidly as the outdoors in the nighttime. When you add on to that the fact that SC/ST households have less fan, less AC cooler, and they're likely to be living in tin roof houses and so on, this inequality is likely to compound. So while we, in the time use survey find that all exposures occurring in the daytime, because that's what the satellite data is telling us, UTCI drops below 32 at night. I think the Harvard Heat Project is basically finding that it does not drop below 32 at night inside the house. It's dropping below 32 at night outside when there's wind and so on. So we probably need to think of inequality in this nighttime exposure also. In that sense, these are not perfect metrics. Would I rely on this to kind of estimate how soon a person is likely to fall ill? Probably not. But I think the point here was to showcase this inequality. I mean, whichever way you cut the data, even if there's error, there's no reason to assume this error is biased towards the caste group. So if as long as it's randomly spread, there is inequality which persists. And that's something that Indian policies are not taking into account at all. So I'll make this answer longer than it already is. But so for example, heat action plans, which many cities in India are developing, they have this, firstly, their thresholds are based on air temperature. They're not looking at humidity, wind speed. So they'll basically say if temperature exceeds is greater than 4 degrees, or temperature is 4 degrees more than the last 30-year average for this city, On the second day, they'll declare a heat wave. This is their official actual definition. The first day is not a heat wave. So if it's more than 4 degrees just for one day, it's fine. On the second day, they will declare a heat wave. They don't take humidity, wind speed into account. It's just pure air temperature. Second, they have the same metric for the whole city. I think the Bangalore data, what we're showing is it varies based on the street you are in. So you need more localized metrics. Third, they have the same solution for all occupations. So what they'll basically say is the Ahmedabad plan, for example, says vulnerable people include construction workers and street vendors. So if you declare a heat wave, then something needs to be done. But what needs to be done? Then there's no specificity, right? So construction workers, you can say stop work. You can't tell a street vendor selling fruits and vegetables to not sell. I mean, their goods will perish. People need to buy fruits and vegetables. So you can't apply the same solution to all occupations. I won't rely, I mean, kind of deviated from your question, but I won't rely on this to tell you health outcomes, but it's indicative is the point we're making.
So one quick thing as you're talking, I could give an argument why feels like is not a good measure, right? Because feels like on average, it may feel very like differently for me, but temperature is temperature, right? So if it's minus 10 degrees outside, how I feel like in a true minus whatever 10 degrees outside versus how you feel could be very different. Let alone that the feels like might have a perceptual impact on how I am viewing, right?
Oh, I mean, I think Google calls it feels like, which is why I said it, but
Oh, no. What I'm saying is as a conceptually,
Yeah,
I'm thinking because it introduces this notion of subjectivity, which is fine if but feels like based on whose metabolism or what, right?
yeah, so that's correct.
Or even
Absolutely.
like access to whatever Jack, because I know, like, I'm sure you have come across people who may say, oh, it doesn't feel that cold today, but others would feel like barely, like at 60 degrees, they would start saying it's cold.
I should say I feel very cold outside today.
Right, yeah. No, today is a different day, obviously, yeah. But anyway, I'll
But-
stop there and open it up, but yeah.
I think, I mean, what we are using this as an objective measure, Google calls it feels like, but I mean, you're right. Different people could be adapted differently metabolically, depending on how your comorbidities are and so on and so forth.
I mean, my only point is if you do that analysis just by temperature, do you find the same results?
Exactly the same.
Okay, good.
Won't
Yeah,
change.
that's the
I mean,
key.
one of the alternate metrics we've used is just pure temperature.
Yeah, and it shows the same
Same
find. So
find.
that also is revealing because it's not adding very much, right? But it's a cleaner measure.
Pure temperature.
Yeah, just temperature. If it's showing
The
same
health, I think the
results.
medical literature would suggest this is, I mean, humidity, wind speed need to be considered, especially outdoors, which is why we use this.
Sure, okay. Yeah,
Uh,
no,
but-
I understand, yeah. All right, okay. Open it
Yeah.
up for
Should we collect a few questions at
Yeah.
once, just for the sake of time? Yeah.
So my first question would be, Arpit, if we just use the female sample, are there any significant differences? I mean, would you observe something different? Because I'm thinking non-work exposure would throw up some differences between, time spent in the kitchen, for example, where women of certain caste groups might be exposed to higher
heat. Yeah. Should I answer that?
Let's take a couple. Yeah.
Okay, please.
I have three questions, so I
Okay, you.
Right, so I think the adaptive measures, you considered only the availability of fan or cooling system inside, but there are other adaptive measures as well for heat stress. And sometimes in different occupation, those reflect very differently, right? What kind of occupation you are in, and there the kind of adaptive measures that can be taken, or based on your you can say if you are marginalized, you are in a low value occupation, and there you have little control over having those adaptive measures in those kind of occupation as compared to another kind of workforce, which is more maybe organized, have better control over the way their work is going to be scheduled. So do you think that this would also can add value to this strategy?
Can I have to Kartike's question?
Yeah, sure.
So, because you mentioned PLFS survey, like which is like urban labor force participation for women is only 20 to 30% across India, right?
Yeah.
Like it's 20%, but for men it's 60%. Like, so what is this data? It is telling the heat exposure for men, or is it? So that's
good
that's the question I have.
Okay, yeah, why don't you respond now? on
Okay.
that?
So in terms of gendered exposure, I mean, you're absolutely correct. Women would be more exposed. One of the major sources of exposure, for example, for women, I mean, which a lot of people are trying to solve is exposure to air pollution and heat through coke stoves, through, firewood burning and so on. But that's indoor exposure, which we are not looking at in this study. But, like I said, that's a critical part of the exposure piece. We just didn't want to use satellite data for it. It's just not, I mean, I think what the heat project is doing, which is indoor measurements, is a much more valid way of doing that than doing satellite measures. So I don't think there's any data set which is nationally representative, which has indoor measures, which allow you to kind of capture that. But that's a critical piece of the puzzle. In non-work exposure also, what we basically found is, we didn't look at gendered analysis. In work exposure, while we are representing averages here, males are exposed 3 times as much as females, purely because they work more. So they're just more likely to be outdoors in the workforce as compared to women. Again, which raises the point that women's indoor exposure becomes important, which is not captured here at all. I think second, in non-work exposure, when we try to disaggregate by gender, what we found is this is pretty equal for men and women. So this 20 to 23 minutes is the same for both. But interestingly, women are exposed outdoors at non-work for, fetching water, dropping kids off to school, so on and so forth. Men are outdoors for leisure if they're not working. So the reason for being outdoors for men is much more discretionary than for women, which was interesting. But I've not put that on the slide here. So yeah, primarily work exposure, like you would guess, males dominate this simply because they are more in the labor force. I think your question on adaptive measures, this is absolutely critical on how people adapt. I mean, this survey captures fan AC, but people change their clothing. I showed that image of women covering their heads and so on. A lot of these adaptations also are occupation specific, and I think they need to be occupation specific. While I've not done any detailed study on different occupations, I think the kind of critique here of government policy is they're taking us same hammer to all problems. So they treat street vendors, like I said, street vendors and construction workers the same. It's you can't do that, right? So for example, Seva has this parametric insurance where if you miss work because of heat wave, you can be compensated for it. You might be able to apply this to construction workers because they can come back and work the next. But like I said, street vendors, you can't tell them sell fruits tomorrow. I mean, people in the city also need to eat fruits and vegetables. 70 to 80% of India still buys that daily stuff from the streets, not from supermarkets. So the same solutions can't apply across different occupations. So they need to be slightly more occupation specific. Our second argument also would be that thresholds for heat exposure need to be different by occupation. Construction worker lifting loads is not the same as street vendor standing in a given place. And street vendor may also have access to shade, for all you know. I mean, that typically they do. In the summer, they'll cover with a tarpaulin sheet or something. So all of these are not the same. And the government currently is treating everything in the same manner, which is not going to work out in the long run. Yeah, I think that. Sorry, you had 3 questions.
So as you know, I also work on heat, so I found this very interesting. My first question was about the focus on maximum temperatures, because we know if we're thinking of human well-being and thermal comfort in general, then actually what matters much more and what's harder to escape are high minimum temperatures in summer. So it'd be interesting to see this analysis done not for exposure in terms of the highest, like the maximum temperatures, but actually for whether the minimum temperatures are above normal. The second, I'm curious about your using caste, because it seems to me it's actually here doing no work other than acting as a proxy for class. Because it's class that determines all the resources that you talked about, whether people have access to decent housing, what kinds of jobs they do, the autonomy that they have in terms of, where they work, how they time their work, the degree of control they have. So, and if we have to think of caste or class relationally, then we have to look at the ways in which the resource consumption of the well-to-do is actually making heat-related stress worse for poor people. So if well-to-do people have air conditioning, exhaust heats, if well-to-do people have private vehicles, emissions, if well-to-do people happen to be living in houses that are made of concrete, glass, and have paved streets, it means a higher heat island effect, which adversely disproportionately affects those who don't consume all of these things or don't consume them to the same extent. So I'd say not class, really. I mean, I don't see caste doing very much work here for you. And the question is sort of, you use the word anecdotally several times, and you ended by saying that environmental justice is something that's been documented very well for India by sociologists and anthropologists. The thing is that anthropologists, sociologists, human geographers, they spend years in the field.
Correct.
To call that anecdotal is
No,
to, I think,
that was no.
That's actually much better.
I apologize for that. No, so I didn't mean anecdotally. Okay, I should clarify that.
In the sense that everything that you said makes sense to me, but it makes sense to me because I've worked on this ethnographically.
Correct, yeah.
So to be told that, oh, well, we cannot know that anecdotally.
I should have used better language. I did not mean that at all. And I mean, I have a lot of respect for that body of literature. And like I said, I'm trying to complement that, not say this is better or that is better, just to quantify this injustice. My apologies. Right? Yeah. Okay. Your point around, I'll go in reverse order. Right? I think the point around taking this relationally is important. Right? AC use of the rich does impact. It does heat up surroundings for everybody else. Same with, air purifiers. You can, make the same argument for air purifiers, cars, ACs.
Air purifiers
not so much.
Private vehicles, sir.
Air purifiers to the extent that it reduces the demand for real solutions which solve problems. But
get into that,
okay, yeah,
private
won't.
Education, private healthcare, private
Lots of
water
lots of
filters that reduces.
I'm waiting for
public.
I'm waiting for sunlight to become a private good. That's the next step. To the point that class determines some of this. Absolutely, class. Like we said, I don't have a grip on the causal mechanism here. But class would definitely play a role. There's no question about this. So, one of the ways in which this residential segregation would operate is who can afford houses in better localities. Having said that, all of our regression models account for class. We still find those impacts. So, in terms of the econometrics, caste plays a role over and above class. So, class does explain part of the variation that we see in the data. It does not explain all of it. Like I said, Ahmedabad, for example, people will say, if you eat non-veg, I won't rent a house to you. And I've heard stories. This is now actual anecdotes, not research. I've heard stories from a Bengali friend who was asked to leave because the landlord snooped around and found bones in their dustbin. And this is a reality, right? And I mean, we all know for practical purposes that people they're trying to exclude is Muslims. But they'll frame it as, non-vegetarian is not allowed because of religious reasons. So that's one way in this city, how this is.
That's religion as well as casteism.
Caste as well, right? I mean, certain castes are more likely to eat. But this could operate in many ways. This could operate beyond, I mean, so for example, if you walk around South Bombay, which is, I think possibly India's richest real estate, right? Streets with high-end housing will be very clean, nice. You walk into slums in South Bombay, overflowing trash cans. So there's also state-led discrimination. I mean, trash cans is not a problem generated by your income. So there's also state-led discrimination in service provisions to different neighborhoods. I'm saying this could also operate.
Based on class. You could be.
Okay, you're saying state is also operating based on class.
Migrants who
Hmm.
are Yadavs, Danyas, Kurmis.
Hmm.
So dominant classes from rural areas who've settled in East Delhi.
Hmm.
They're not low caste per se, but because they are low class as a working class.
Correct.
And they don't have rights in the city.
Hmm.
They're likely to have all these factors that make it hard for them to be able to afford decent housing.
Correct.
Steady work and so.
Yeah.
What I'm saying is, I think class is much more important. The class is doing a lot of work, explanatory work, in terms of looking at in terms of incomes and assets, shaping people's exposure, shaping their attempt to insulate themselves. And I don't see
Correct.
caste being quite so prominent in shaping those life conditions and life chances.
Correct.
In this particular survey.
Okay, I think
No,
we should.
Fair enough.
Yeah,
I mean,
we should.
numbers are telling us,
Yeah.
what they are, but after, I mean, this like econometric detail, but after controlling for all of that, the workers, okay, I should.
That's
Yeah.
okay. I think you can follow up
No, sorry.
after that. But I think if students have to go, I just want to feel free to whenever you need to, because our time is until 1:30. Right?
Formally done.
If you
but
have
for-
class or anything, so please don't feel shy. But yeah, if you want to stay around, I think Arpit is going to be here for a bit more.
recording this part, and then appears as
Yeah.
Okay.
So thank you once again. Let me take this opportunity to thank